We're here today, we're talking about the future of the wide area network, and in our instance, this is the SD-WAN debate. Those of you who joined us at IP Expo yesterday will have heard many of these slides before. Perhaps you're joining us with your colleagues who couldn't make it at the event. But what we're finding at the moment is there's a bit of a paradigm shift going on. The network exists to serve applications and services to our users. But the network becomes this kind of elephant in the room. We've got all these wonderful things we'd like to do, but realistically, the network just isn't capable of delivering those for us. So there's a bit of a change around at the moment, and the technology is finally catching up with the requirements that we're getting to a position where really I think Citrix have got a very compelling story to tell. And that's why we've dedicated this session here, the essential guide to the Citrix SD-WAN solution. And I can give you some breaking news this morning that has literally just hit our inboxes. As a specialist partner, we get to know about some of these things perhaps a little bit before some of the other partner base in the community. And the Citrix Cloud Bridge solution, as we know it, is going to come underneath the NetScaler branding very, very soon. You'll see that. It's probably going to be announced officially at Synergy, I guess. So where you see Cloud Bridge in this slide deck at the moment, replace that with NetScaler. Where you see SD-WAN, that is still relevant. There may or may not be a hyphen in between the SD and the WAN, but we'll see how that goes. But a little bit about cloudDNA in the first instance, just to give you an indication of who we are. We're the only dedicated Citrix cloud networking practice here in the UK. We are NetScaler and Cloud Bridge specialists, and already my slide deck is out of date. Look at that, second slide in, but never mind. We're a little bit unusual because we focus on those technologies. We don't really get too heavily involved in XenApp and XenDesktop, and I'm really pleased to say, I'm proud to say that we were the very first global Citrix partner to gain the Networking for Data Center Specialist accreditation. This is a real deep dive focus that we've had since the beginning of time as far as cloudDNA is concerned. And having this specialist accreditation gives us some great inroads into the products and teams over at Citrix who focus on this networking stack. So I'm delighted in our session today, this future of the wide area network discussion, that I'm joined by one of the guys that's right at the very heart of the NetScaler SD-WAN solution. And despite his job title having marketing in there, this is as technical as you could want it to be. My name is Al Taylor. I'm the guy on the left. And to my right and on the right of your screen, perhaps I'll introduce this morning to you Mr. Barney Norton. Barney, good morning.
Hey, good morning, Al. Thanks for having me, and thanks to everybody who's online right now.
We're going to run through some of your slides, Barney. We're going to use some of the images that Barney's been talking about to folks all over the world. And just to give you a little bit of indication in here, as you can see, Barney's job title is quite clear to see. What Barney tends to get involved in, though, is running around the world, and he clocks up more air miles than the International Space Station, it seems. But Barney goes around the world talking to people in similar organizations to your own, and listening to those challenges, listening to those concerns, and understanding how the Citrix networking stack can help out with some of those challenges. So Barney has this huge amount of information that he's gathered from across the globe, and he's going to share that with us. Barney, I'm going to let you take the stand there and perhaps talk us through some of the slides.
Hey, well, thanks, Al. I'd like to reiterate something that Al said about my job title. I'm a global resource, and when people see marketing in my title, it kind of sometimes puts people off. But yeah. I'm more, I think, what I call a super SE for the team, for the cloud networking team. And so one of the things that I like doing is, from an engineering standpoint, is, first thing in working and networking when you have a problem is what's the problem?
Yeah.
Right on. So what's the problem with the WAN? The problem with the WAN is that it just doesn't meet all of the challenges, all the new challenges for applications. And being Citrix, VDI is very important to us.
Sure.
And as we begin to increase the user experience with VDI, the amount of data that's required for that experience has increased significantly. And so maybe this is selfish, but SD-WAN for us is very, very important, especially for VDI. But it extends across pretty much all the other applications that run over the WAN. Things that used to be not important, video used to be auxiliary to most enterprise operations, is now important. Even voice over IP. Well, voice over IP has been around for a long time, But now the aspect of it has changed. So there's Link, Skype for business. Those are all very, very important. Video is huge. Video is probably one of the biggest, fastest growing aspects of data over the WAN. And the characteristics of it make it so that it's not optimizable, but it's still critical to the business. And so we need to make some adjustment to accommodate it. So optimization. So I'll talk a little bit about optimization later, but optimization still has an application. But over the, let's say, the past 4 or 5 years, it's changed. So I talk to people, WAN administrators, and they're all screaming help. What can I do?
Yeah, sure.
Well, there's a solution for things like digital signage, where customers and the retail environment, they want to do marketing, banking environment where they want to do marketing and be able to go out directly to their customers and touch. Web applications have changed, and definitely have in the past few years. Video-based content, I think I mentioned that before, but you can see by the graph that the requirements in the load on the WAN is increasing. The cat videos, if you're backhauling your internet access, and maybe not targeting directly Millennium users, but Millennium users are used to having that access.
You know who you are. You know who you are if you're watching this, yeah.
Somebody's watching a cat video right now.
There's a lot of people watching a cat video, and a sneezing panda, I expect, as well.
Yeah, exactly. So the spend for WAN is increasing, and this is only going to get faster. It's only going to grow more. So you have to be prepared for it. So, MPLS has been the standard, right? But the internet has always been there. And since maybe the early 2000s, when site-to-site VPNs, IPsec VPN tunnels became popular or accessible, a lot of enterprises tried going that way. But unfortunately, there's no SLA associated with it. You can get some kind of, let's say, a general capacity SLA with internet. But from a connectivity standpoint and a quality standpoint, it's just not there, right?
Yeah, sure.
MPLS has been the standard. And these are general numbers that we use. We have this company called Telegeography that does this kind of studying worldwide. These numbers may vary a little bit, but it's just an example of the difference in the cost. Make sense?
Yeah, absolutely. And I think in the note there, you look at London there, the MPLS figure, $90, around about 60 pounds, and this is assumably a meg a month.
Right.
These numbers are looking at. We're aware of places in the UK that have got more remote locations. London is the cheapest place by a long way in the UK to get comms because there's a lot of competition here.
Yeah.
But as you start to move up north, you go into the more regional territories, going out into Wales, into the southwest, up in towards Scotland. Those numbers are multiplied quite significantly. So these are very relevant figures to look at. But without a doubt, the internet side of things tends to stay fairly flat. It tends to stay fairly stable. But I guess if anybody's homeworking and trying to go through their business, and then when the kids come home from school at 3 o'clock in the afternoon, they all hit the broadband, they're all going out watching their videos, their cat videos, those are the ones. Then that internet service isn't very stable, and that's what you mean by SLA, right? Yeah, well,
we use MPLS because MPLS has an SLA associated, and there is an illusion, if you will, it's somewhat static, that it also means there's an SLA associated with your application.
Okay.
And sure, MPLS, and I'm generalizing here to be sure, so for sake of time, that MPLS has a queuing mechanism in it that allows you to graduate your services. Voice at the top, whatever else at the bottom. But to be sure, that doesn't assure delivery. It just gives you a queuing and an ability to forward so that you can have some degree of certainty that maybe your data is going to get there. But I think anybody who's used MPLS has an outage. Anybody who's used MPLS has possibly had a queue overrun on their voice queue on MPLS and had a brownout.
Yeah.
Okay, so there is something that says it's going to be up 99.99% of the time, but there are outages all the time. I think every administrator, it's the thing that we live with, right? And internet, on the other hand, is cheap, generally speaking, inexpensive. Even if you get business-grade internet, it's easier to get. negotiation of price is you can have somebody come out and you can have internet in pretty quickly, but it doesn't have that queuing mechanism. It doesn't have that assurance of capacity all the time. So there's a lot of risk with it.
Yeah, sure.
Cool. So definitely, we went out, to add some validity to the market. Gartner's gone out and asked people, what is your spend? What do you think you're going to do in the future? So to show that there's actually a market there, it comes back that the WAN is one of the most expensive components of a network, right?
Yeah, sure.
It's expensive from a monetary standpoint, and it's expensive from an administration standpoint as well. And that the concept of hybrid WANs, okay, that administrators are actually really actively looking for some kind of solution to supplement what they have and reduce cost. SD-WAN is the biggest cost reduction and performance opportunity, but cost isn't everything. There has to be some kind of overlay that assures a level of service so that when you're using the public infrastructure and the private infrastructure, that you can make sure that your applications are going to work and the connectivity is going to be there. Does that make sense?
Yeah, I guess so. From that, in that instance, then the software-defined part of the WAN is the software, the operating system of the solution that's deciding path selection, it's deciding about application performance optimization, SLA-based thought process in there. So I guess then the software-defined part, because we're starting to see a software-defined networking, it becomes kind of the intelligence in the background about how this stuff all plugs together.
Yeah, well stated, Al. But so let's talk about defining a little bit. Getting some requirements from it.
Yep.
To a degree.
Okay.
And Gartner tried to do this, but they came out with a kind of a sort of a general framework for what SD-WAN should look like. And I'm going to read from the slide, pardon me.
Yeah, go for it.
So create a WAN solution that can optimize traffic flows between the internet and the MPLS for all applications. So there's two key points in that. One of them is optimization, optimize, okay?
Yeah.
And the other one is the internet and MPLS, combining them into one logical circuit, okay? So there's two things in there. And certainly as we go through, you'll see that the Cloud Bridge far exceeds both of those expectations.
Okay.
But as a general sense, what are the SD-WAN minimum capabilities? Well, this is the wish list for any WAN administrator out there. Always on branch.
Okay. Yeah, good luck with that.
Yeah. Well, I hope in the next few minutes we'll maybe describe something to you that will at the very least assist.
Okay.
Right? Okay. So it's got to be up all the time. There's got to be a mechanism that assures not just that some level of capacity, but that it works. There's nothing like being a WAN administrator, being at the soccer match, the football match.
Thank you. Yeah.
Yeah. And getting a call that some branch in India can't get to their applications, right? So it has to work and has to have resiliency. It has to have more bandwidth, right? But you got to get that bandwidth at a good cost. It can't be as expensive as doing MPLS, right? Mm. So there has to be additional functionality, lowering the cost, and that's a big part of what SD-WAN does. And I think as I go through explaining, describing a little bit further, you'll see where those savings come from. Then there is application SLA. Look, I think this is the most important component of almost everything, and I think that I may have used the word application 30 times in my presentation yesterday.
Yeah.
Because really, and I use this analogy, and it may be very simplistic, and I apologize, but people would use 2 cups and a string if that's what would make their applications work.
If it worked.
If it worked.
Yeah, sure.
Yeah, that'd be the easiest thing to do. But it doesn't. There's no assurance. Applications need to work, okay? Regardless of the connectivity, the quality of the connectivity, or the different types of links, WAN links that you have, mm-hmm. Applications are the most important thing. And whatever solution, SD-WAN solution you look at or think of, this has to be a priority.
Okay.
Right on. So a key thing is that if you look at the cycle of getting MPLS, it's a long cycle. You go through and negotiate contracts. You go through the process of doing configuration. You go through there's things that stack on each other. that just make adding the services just MPLS difficult. Well, I think that we have an interesting, architecture for this from CloudBridge, where we can add these services very quickly. Typically, internet is a lot easier to get, and you likely already have it in the public infrastructure.
Yeah.
Or let's say you have two MPLS circuits. One of them typically people use, and maybe they have a few applications running on the other one. But CloudBridge allows you to use both of those MPLS circuits and combine other connection methods very quickly, okay, with just a few couple of configuration, and then advance your services.
So that's always been another thing that the folks that we speak to here in the UK and across EMEA are always citing, that MPLS links are, while they have that stability to a certain extent, that known quantity of 5 nines uptime is a dream world. Perhaps 4 nines uptime is more realistic, and a couple of nines in many instances you're happy with. It's not a very flexible way of actually being able to deliver things. You can't take control of these things, and maybe even QoS rules are out of your control, or quality of service rules. So there's some challenges around that MPLS link, just running it on a day-to-day basis. Yeah.
Well, that's very interesting that you mentioned the QoS rules, because it's those are the things that enterprises use to be able to classify the applications from a service level. But if you go between geographic areas, the QoS settings for those different providers it changes. So it's difficult sometimes to map all your applications here in the UK to the cost levels, let's say in India, or to Australia, because they just have different service agreements.
Yeah.
Right. And so that affects your applications in the way they run. And I think we have a solution for you.
Okay.
Cool. So now that we've kind of defined it, what does CloudBridge, what are the key capabilities and features, and how does CloudBridge do it, right? So in a nutshell, we bond different WAN link that can be different. It can be 4G, dual MPLS, MPLS and internet, MPLS and 4G, and bond these circuits together so that you have an aggregate bandwidth that equals the total bandwidth of all the connected circuits. Does that make sense?
Okay, so say I've got a 10 meg MPLS, I've got a 100 meg broadband, I've got maybe 20, 30 meg that's floating about on a very, very good 4G.
Yeah.
If I do the math, set them all together, what did I say there, 10? So somewhere around 150 meg as a combined aggregate is what we're getting.
That's right. So you have actually 150 meg, right?
Okay.
And that's kind of a special to us, because if let's say that I'm running my enterprise applications in the daytime.
Yeah.
Okay. And that the applications are spread over qualitatively spread over the different links. At night, you're running a replication app, right? To meet your SLAs for your replication, you have access to all of the capacity.
Yeah.
So you have really, for that flow or those jobs running, 150 megabits.
Okay.
100, megabits of capacity.
Sure.
Not just the capacity of one circuit. Right, so we can load balance these flows over multiple divergent links.
Okay,
cool.
Yeah,
that's really a big thing, a big differentiator for us. So we do one of the things, and I'll talk a little bit more about it here, is that we don't use IPSLAs specifically. IPSLAs are great, and I'm not demeaning them in any way. But if you're going to provide full application end-to-end quality of service, if you will, then you need to have a high resolution way to monitor the circuits. And in CloudBridge, we do that bidirectionally. So we know the path and we know the state of the path with every packet leaving and coming into the branch or the DC. That gives us the ability to do things, to react to changing conditions very, very quickly. And I think we have some other slides we'll talk a little bit more in detail on that later on.
Great.
So we're packet-based. I think maybe those first two things, the first two descriptions of what we do, maybe lead up to the fact that we're packet-based.
Okay.
We're not flow-based.
Yeah.
We're not route dependent. Okay, as an overlay, you don't have to change your circuits and routing. And we have an application SLA attached to that, because that packet-based enablement gives us the ability to watch data as it flows through the SD-WAN. okay, and apply an SLA to it based on not just certainly the requirements of the application, but the qualitative nature of the circuit that it's going to use.
Okay.
Okay. That means loss, jitter, latency.
So this is perhaps something where folks are going to be familiar with other solutions that will recognize when a particular link, and I know we're going to speak about some of the old alternatives, I guess.
Right.
Historically, these kinds of solutions, these kind of mechanisms have been based on an outage. And if you've lost a link, that's when the decision is made to transfer to a different route. Whereas in this instance, then, having the ability to understand the quality of link, not just the fact that the link is still up and running, there's a big difference between the two. And any network administrators listening in will understand exactly that. As you said there, packet loss, jitter, those kind of things that are very, very relevant, particularly to live traffic services, and those could be voice over IP, or they could be obviously XenApp XenDesktop type services. Those kind of situations are a slightly different way of looking at it.
Right. So, it's not just the loss of a circuit. It's how much jitter and how jitter affects a particular application. Right?
Okay. Yeah.
Let's say voice. Voice can actually handle a little bit about latency, right? It's okay with latency because of the way sampling is done, octave sampling and things like that. There's a lot of silence in conversation, right? So, but it's very, very sensitive to jitter.
Okay.
Right? So loss, latency, and jitter, or a combination of those things that may exceed the requirements for specific application, being packet-based, we can move that flow or that on a packet basis in less than 2x RTT to a next best circuit or the best circuit for it. Okay. Does that make sense?
So 2x RTT, just for those who are slightly more commercial, that's 2 times the round trip time of a packet. So there and back twice is what we're getting at, yeah?
So if you have 20 milliseconds of latency before you can tell that anything has gone on in a call, or you've circuit even your MPLS has dropped, let's say.
Yeah.
You'll never see a difference in the phone call.
No, that's super quick.
Yeah, it's very quick. And being packet-based is key to that.
Right? I guess there's no feasible way you could do it any quicker, is there really?
No, I can't think of it.
I can't think of a way to do it. There's no way to do it.
If you look at the OSI model, right?
Yeah, sure.
Right? And I mean, it is the way, probably the best way, but it is. Well, I am a little biased, but it is the best way to do it, right?
Okay, I'm happy with that.
So security is important, right? Security, if you're going to run your applications over the public infrastructure, you need security. And I'll talk generally to that later on. But the appliance provides that by default. Okay, at different levels, and I'll show you some of that here later on. And then, something that is new, a little bit new, recent release of a product is this thing where we add optimization. So optimization has been around for a long time.
Yeah, sure.
But the requirements for it have changed. Certainly the applications have changed. So, we give the option, and I have a couple of slides on this later on as well, where, we can make decisions strategically of where optimization is needed, and you can combine that in the same appliance with SD-WAN.
Okay.
Cool.
Yeah, sure. So this is the traditional WAN optimization that those that are familiar would have perhaps had a WAN scaler back in the day. We used to love WAN scaler. That was a good name.
Yeah, WAN scaler and cloud bridge optimization.
Yeah, a branch repeater, if you're familiar with that as well. I guess this is the traditional idea of TCP optimization, deduplication, compression where you can do it, that kind of stuff.
Yeah, well stated, Al. That's exactly what it is. So you can get those in situations. I have a couple of slides later on that speak kind of to where it might fit. Right?
Yeah, because that's definitely been something we've seen in the past where optimization is perceived to be the way to fix the problem. But perhaps it's more about a bandwidth issue or even a resilience issue that they're looking at. So this kind of starts to fill that gap then, yeah?
As we say in the States, you took the words right out of my mouth.
Oh, I'm sorry about that. But I know you've been talking all week to people, so I figured I'd give you an easy time for it.
Optimization, this is a change in thought, right? People, generally the administrator, when they were running into problems of congestion, and delivery, they would think immediately optimization. Applications have changed in the last few years, right?
Yeah.
Where optimization may have less effect. And sometimes it's just about getting more bandwidth.
Sure.
Right?
Okay.
Getting more quality bandwidth, right? So, kind of to reiterate what I said in a more colorful way, is starting at kind of at the lower right-hand side is measure performance in each direction.
Okay.
So that the outbound side of an MPLS or an internet circuit may look bad,
Yeah.
but the inbound side may be fine.
Sure.
Okay, so to be able to differentiate that in a bidirectional way means that if a packet comes in to a branch and it has information that says that that circuit, particular circuit, had a lot of loss and jitter on it,
Yeah.
then maybe using another path on the way back
Okay.
would be best.
I guess that would be also relevant then in a traditional, for want of a better term, cheap ADSL type of solution where you've got a different
Sure.
amount of bandwidth going upstream than you've got coming downstream.
Yeah, the congestion characteristics might be different in either in one or more directions, right? If you have an asymmetric circuit.
Yeah, sure.
Right on.
Okay.
And so I think that the two left-hand side, sensitivity to latency, jitter, packet loss, and reserved bandwidth for priority apps, those are tied together.
Mm-hmm.
I don't think you can have one without the other. Okay, so what we're talking about here is tying the requirements of the application to the actual real quality of the bandwidth, of the capacity, right? So that if your MPLS, and we would typically hope it would be, is the best place to put that, then that's where we'll put it.
Okay.
Right? In the case of voice, actually, we duplicate the packets down, but two of the best paths, okay, with the best circuits, WAN circuits, and as part of that, we absolutely assure delivery, unless of a absolutely catastrophic failure of everything. We absolutely assure the delivery of voice with a very high MOS score.
Okay, so just so I understand that then, so we're effectively saying in an instance where something like voice, and I mean, again, if you're a call center operator, if you're using voice as a core component of your way to communicate with your team or your way to communicate with your customer base, then clearly voice is very, very important. So in that sort of situation, if you wish, you can actually duplicate the packets. Do I understand that right?
Yeah, that's right. I mean, because we have this packet-by-packet monitoring of the circuit, we can sense that which circuits are best.
Okay.
And we'll send the same packet down both of them.
Okay.
Right? And then on the other side, whichever arrives first, we'll reassemble into the flow and then move it on to the user.
And then assumedly just discard the spare packet.
That's right.
So you've got a high availability packet choice that's going from both sides there. But that's a real belt and braces way of doing it, isn't it?
I might plagiarize that one.
Yeah, why not? I've been using your stuff all week. Go for it.
Okay. So how does it work? So certainly there's a lot of other more in detail on how it works. But the way that we do it is we encapsulate or tunnel in port and UDP, port 4980. Okay. And part of that encapsulation, it adds a very, very high resolution timestamp.
Okay.
And there's some other information in there, but one of the most critical parts is that timestamp that allows each branch, well, first off, it allows some hinting, okay, so that the one branch can signal to another branch that something's going on. They saw some problems with the circuit. But it also allows, when the packets come into that appliance or that branch, for that branch to be able to see if there's jitter, loss, or latency on it. Okay.
Yeah.
So that's a critical thing. And the fact that we append this we tunnel every packet that comes through means that the resolution of our monitor is as fast as the packets come through.
Okay.
So if you're using it, then the appliance knows what's going on in the circuit. So tunneling happens in both directions. And we separate those. We have an outbound and an inbound. And we're able to separate those from a logic standpoint so that we know that from a access standpoint that the inbound may be good or the outbound may be good or the outbound may be bad.
Okay.
Cool. So, and then we have, of course, add a layer of security. By default, you can turn it off if you'd like, and we have different levels of security, but by default, we have security built into the appliance so that even in the MPLS, it's important to have some degree of security.
Okay.
And if you're using the public infrastructure, it's absolutely essential that you have security. So we provide that as part of the tunneling capability as well. Okay. Cool.
Yeah.
So we refer to this as real-time path measurement and selection. Okay. The UDP encapsulation is important to selecting the best path based on real-time metrics. So, you differentiate that from using something like IPSLA or a ping, for that matter. The ping in the IPSLA don't have the resolution, the depth of resolution, and their ability to react to things very, very fast. And it's a key differentiator, and I think it's, I think it would be key for delivery of any application right now. So we can optionally have the ability to bias towards a particular path because we tie the application to a qualitative measurement. So as traffic moves through, we have a hierarchy, voice being at the top, let's say, and sysmin and assist as an example being at the bottom, so that regardless of what happens in the circuit, from an aggregate standpoint, the qualitative requirements for voice migrates regardless of the conditions of the WAN.
Okay.
Does that make sense?
Yeah.
Cool. So let's move on a little bit to security. So we have security built into the appliance. And there's different levels. The lowest level, you can get 128-bit encryption.
Okay.
At the higher levels of encryption, we have an IPsec tunnel with a 140-2 level crypto library. Now, under full disclosure, it's not certified,
okay,
but we use that library. So that's a pretty significant library for from a security standpoint. And it makes us interoperable with some other IPsec vendors. Go ahead.
Okay, well, just exactly that. I mean, the FIPS 140-2 was always pretty much as high up as you were ever going to go and see, certainly in the UK markets. I mean, that was really, historically, we only ever saw that in central government and military type of installations. There's some other folks using it, but that level of encryption, that library in there, I appreciate there's some hurdles to jump and some hoops to jump through to get your appliances certified. But if you're using that library, then really it kind of negates the conversation, or it negates the argument that we don't want to use the public internet because it's not secure.
Yeah, I think that if you're involved in security to some extent, then, there was initially the idea that MPLS was your environment in the MPLS cloud. But really, as time has gone by, I think there's been some stories out there that talk to people getting hacked or getting into the MPLS cloud and being able to see people's data. So it might be important, if it's part of what is done by default, to provide some security there as well.
Yeah, sure. Cool.
So now we've talked briefly about kind of how we do it, right? And so I think that within the scope of what we're doing here, I think we kind of solidify where we are and what we're trying to do. It's all about logically bonding these multiple distinct WAN connections into one piece of capacity. Okay? It's about path selection based on the active state of the link, the state now of that link. Okay? It's about maintaining security and sending packets based on application needs and link performance. I can't say this enough. It's all about the application. Again, going back to my little string and 2 cups analogy.
Yeah,
right?
Sure.
So to ensure that your applications get delivered, right, you need this kind of, I think it would be important to have this kind of monitoring capability.
Yeah, sure. And I guess, there's an awful lot of these SD-WAN vendors coming into the marketplace now. So the due diligence from an administrator's point of view, from somebody who's choosing one of these solutions, is to really have a deep dive into that product set and have a deep dive into that feature set and check that application layer of SLA thought process is in there. That application needs is really something that's relevant in there. I guess that's a sensible option, isn't it?
Yeah, that's again well stated, because it's the most important thing to the administrator.
And if we look here on this slide at the moment, we can see that the visual representation of an internet, an MPLS, and a 4G/satellite link there. And I guess then, again, listening to conversations, listening to comments from folks that we've introduced this to over the last year at cloudDNA, there's still a requirement in some instances to be able to say, well, I want to make sure that certain traffic uses one of those links, or certainly if we're using satellite or 4G links, those can be very expensive, even in comparison to MPLS on a bandwidth basis. So the path selection, is that a fully automated thing, or do we have some control over that as an administrator?
So we have some control. We have a lot of control, because it's definitely satellite specifically, and 4G to a large degree have a different cost structure, right? And so you would like to use those if if everything else fails, maybe.
Sure.
But you may not want to use them on a continuing basis.
Okay.
So we have this concept called a metered link, or a link of last resort. So we'll monitor the link to make sure it's active, because we wouldn't want to switch traffic to 4G if it wasn't up and running.
Sure.
As an example. And then if everything else fails, if your MPLS fails, your internet fails, and your 4G is still there, we'll switch the traffic over at that point.
Okay. Yeah, it makes sense. So you've always got that, like you say, the link of last resort is the perfect way to describe that, isn't it?
Yeah.
Where there's a significant cost implication, and potentially 4G isn't going to be as stable or as great as your MPLS and internet, then it's there as a backup if you've got those mission critical services. The other thing I note here as well is, I mean, we deal with a lot of folks out in the construction industry, home builders, those kind of guys that are out in civil engineering, where it's challenging to get, maybe they don't even have the capability of running a copper cable to a particular site because there's no postcode there. It's really out in the sticks somewhere. In those kind of situations, we could perhaps take a portable building, we could perhaps take a satellite link on the top of it, maybe a couple of 4G routers in there as well, bond all that lot together to give us some form of service from day one, maybe delivering live services like XenApp XenDesktop, and then as the provider catches up, might be 6 weeks, might be 8 weeks head down, but into a year-long project, then we can start to migrate traffic over to those other links.
That's a really good example. Let me give you another one. Actually, if you go to citrix.com, we have some success stories there, and one of them involves the Agriculture Department of Denmark, where they are on a boat. Okay, when they're tied up to the pier, they have a copper connection. Okay, but when they disconnect, they go up and down the coast of Denmark, enforcing the fishing laws and regulations. They switch between different providers. They use cloudBridge to do that, and it does it seamlessly and without interruption to what the people on the boat are doing. And it's a really good example of what you described.
Okay.
And I think maybe going even a step further, where satellite is the link of last resort, right? And as they go across the coast, different 4G providers come into play. Or if all of 4G is out of range, then all the traffic goes to satellite. And cloudBridge makes this transition between these available circuits seamlessly and without the crew or the enforcement officers even knowing it's happening.
Okay, because this is an overlay technology. From the user's perspective, they don't know which route is going on. I mean, obviously, an admin is going to know that and have the tools to be able to do that.
Monitoring, right? So yeah, right on.
Okay.
So that's
great,
cool.
So a typical solution then, Barney, how's that look?
Well, so let's say you have a single data center supporting multiple branches, and I have referred to using MPLS and the internet, but this could be a situation where you maybe have two MPLS circuits. Okay. Right.
Yeah.
Single data supporting multiple branch offices in locations with MPLS 1.5 to 3 megabits. You can see this is kind of biased toward the U.S. market a little bit.
Yeah.
Depending on the branch size. They have a separate internet access connection for the customer Wi-Fi network. So in this case, just to put it encapsulating a little quick story, is that the branches already have internet. Right now they're using it for customer Wi-Fi. Okay. Right? But it's there. And it's maybe could be 30, 40, 50, 100 megabits, right? And then they're using a 1.5 or 3 megabit circuit for their actual data. Wow, there's a big offset there, right? Yeah. So the data center is hosting Citrix XenApp and XenDesktop, and there's some other enterprise applications, of course, voice. Okay, they're all sharing that 1.5 to 3 megabits. So the challenges is that you just rolled out a new video training application, for instance. Okay. And boom, the quality of everything, including the business critical applications hosted through XenApp and XenDesktop, begins to suffer. And the video won't play. So what's the solution? Add the cloudBridge SD-WAN, and the SD-WAN, so then cloudBridge SD-WAN can spread that load, take advantage of the additional bandwidth, okay? Provide a layer of security, provide connectivity back to the DC, and increase the bandwidth. I don't know, that's at least a couple of hundred-fold. Yeah. So, and there's no single point of failure for an application. If the MPLS fails, then the quality of service mechanism that extends across all of the bandwidth will migrate. Voice will get get priority in the circuit.
Okay.
Okay. XenApp will get second priority. Okay. And the guest Wi-Fi will be down somewhere down at the end. And we can move this back and forth, always preserving the quality of the applications, based on the circuit. So what do they get? Okay. They get 100 megabits of capacity at all for just the cost of the implementation of CloudBridge. No single point of failure for a particular application. We can do packet duplication between the internet and the MPLS for voice. Improved application performance because we just threw another 100 megabits of bandwidth at it, right? And we did it with just a couple of as an overlay with just a couple of configuration commands. And we actually can increase the efficiency for all those bulk applications like sys. So if you have file shares, or if you're doing printing is absolutely huge, right? So you can offload that from the MPLS and put it on the internet. It'll get the bandwidth it needs, right? And then with MPLS being a more quality circuit, those applications will get what they need to run appropriately on the WAN.
Okay, so I guess then in a true salesman's kind of close there, you can kind of go down the line of saying, so is it the service quality for the users? Is it the additional resilience? Is it the additional bandwidth to deliver more services and potentially migrate into these video link VoIPs and all those kinds of things? Or is it the reduced cost that you don't like, Mr. Customer? Really, it covers all bases, doesn't it?
I think it hits everything.
Yeah.
It hits everything. I think it covers the gamut of what the expectations are. So I get asked the question all the time: is this link load balancing?
Yeah, sure.
Well, it's much better than link load balancing. Link load balancers, and I can read through the lines on the slide here, but I think it's not bidirectional. It doesn't have the ability to sense, can't make decisions on the requirements of a particular application. It can't do packet duplication. Okay, and in essence, it allows you to spread the load maybe, but it doesn't. There's no assurance of delivery of the application data.
Makes sense, yeah. And I guess in that instance as well, in a traditional sense, and I guess we've all seen this as well, when a link load balancer fails over traffic from one site, from one path to another, you generally then, there's often the case of, do you need to then restart the session? Is there an impact on the user in that instance, or does the user recognize nothing? There's no change.
No change, and I think that's key. So what about, is it routing, right? So no, it's better than routing, right? You certainly 10 seconds is a marketing term, but you can tune routing to fail over, maybe quicker than 10 seconds.
Sure.
But you have to wait for what we call a brownout period, where the routing is sensing that the circuit's down and it needs to fail over. Then you have a blackout, where, as you mentioned before, the sessions need to restart. Okay, the calls drop.
Yeah.
The sessions for ICA drop. Okay, there's an interruption in the bulk transfer or a print job, and in some cases, still some legacy applications have primitive TCP stacks that mean that if the job stops, you have to go back in and restart the job.
Okay. Manually
restart the job.
Yeah.
And with our solution as an overlay, we don't require any ownership of the IP space. They don't measure link quality, okay, to detect loss and latency.
Okay, so this is back to that original point, isn't it? Where the quality of that connection is just as relevant as whether the connection is still live or not.
That's correct. And then it doesn't assure delivery of application flows. And CloudBridge, to be from a routing standpoint, CloudBridge works as an overlay. So if you decide to implement CloudBridge, you can do it without changing the routing and delivery that already exists in your network, which is, makes us a really, really viable solution as you, for instance, roll things out or want to add services in a targeted fashion.
Again, one of those old situations in the old school WAN optimization days is, we can do all the bells and whistles on our box, but what happens upstream, what happens elsewhere, and it starts to become a way, way bigger engagement than you thought it was going to be. But this is an overlay. It's practically invisible from the carrier's perspective.
It's invisible from the carriers, and we do things like packet retransmission. Okay, we do packet aggregation. There's a whole host of things that we do, including things that that work with the product to be able to ensure delivery over internet. Okay. For instance, some internet circuits, some providers will shut you down if they think you're using, public infrastructure for business. Okay. Now, we have things built into the appliance that gets past that, UDP hole punching and things like that. But the whole host of things that enable our capabilities.
So the usual thing then, obviously, it's got a Citrix badge on it, and we have many folks that believe that marketing propaganda, that FUD that comes out from third-party WAN optimization vendors, who proclaim the possibilities for their product around XenApp XenDesktop traffic streams can deliver all kinds of wonderful things, but Citrix own the ICA protocol or HDX protocol if you're reading those marketing bits, and Citrix obviously have the intellectual property around CloudBridge, formerly CloudBridge, now NetScaler SD-WAN. So the obvious question is, in a XenDesktop or XenApp heavy environment, what kind of typical benefits we can see? And I guess this is where this slide comes in.
So yeah, we have the best, optimization solution for XenApp XenDesktop, and certainly we do a whole host of other TCP applications. So, and we preserve that as we move toward doing SD-WAN, right? So, as we do in the WAN optimization product, we can distinguish between the virtual channels of what's the things that affect the user experience and what are the things that don't. Okay, and we can leverage that knowledge that we have about in both configuration of the XenApp and desktop environment, and leverage that to the way that you use optimization, maybe, and for certainly SD-WAN, right?
Yeah.
And so we preserve that through the product set. One of the key things is having those branches always on. That's a big plus.
Yeah, where a business relies on, and obviously this is the case in many instances, whether it's delivering legacy apps and services, or it's just a simple case of the whole XenApp XenDesktop piece. It's just a compelling reason to aggregate all the services, give users a single point of access to all this stuff, to reduce the bandwidth on the network in the first place, because it's a very lean protocol, obviously. So being able to ensure that those services remain active means the business keeps functioning.
Yeah, and you can, because we do this on a packet by packet basis, you can establish a MOS score, the same kind of score that you use to measure the quality of voice.
Okay. You
can assign to your XenApp XenDesktop so that you can measure the quality over a period of time. And, certainly the visibility, the additional visibility that we have with the products that go up the product stack for Citrix, like Insight.
Yeah.
Right? And that's the capabilities of NetScaler, NetScaler Gateway, and all of those work together and give you a view of what's going on all the way from the lower layers of the OSI model all the way to the top.
And this is gold dust, surely, for an administrator, support admins, those kind of guys that need that information. Having that level of visibility means they know exactly where to start the remediation exercise. Sure. Rather than Citrix is running slow. It's Citrix is running slow, let's get some facts and let's find out why. And these kind of metrics, this kind of visibility is gold dust for these guys, yeah?
So it goes beyond ping and trace route for sure.
Yeah, by some margin.
So what about CloudBridge? So we have right now 3 different flavors of CloudBridge. And again, as Al stated earlier, NetScaler SD-WAN. We have a virtual WAN edition, which is really what we've been talking about for the last few minutes. There's a WAN optimization edition as well. So there's still great application for optimization. If you have, and I'll actually discuss that in a slide coming up. And then we have the Enterprise edition, which combines the capability of optimization and SD-WAN into a single appliance with a single management interface, and a single reporting structure.
Okay.
Very powerful. So you can then now take these different capabilities, put them where they make the most sense. And that's actually very important. Mm-hmm. In the past, we thought about using optimization because optimization was about getting 10 megadata in a 1 meg pipe.
Sure.
Right on.
Yeah.
And so that kind of covered everyone because MPLS is expensive, it's hard to increase it. Well, with the virtual WAN, Now we can just throw bandwidth at it. So instead of having to fit 1 meg into a 10 meg into a 1 meg pipe, let's just give it 100 meg, right? And so that solves the problem. I think I need to change my arrows here.
Do you know what? I was just going to say that because you're absolutely right. I think what we're basically saying there is it's a latency perspective we're looking at. WAN optimization is going to give you the greater benefit where the latency is higher.
The higher for remote branches where latency or maybe you can't get more bandwidth.
Yeah, sure.
Right on. So that you can make a decision which one you want to implement, or you can do both of them in the same appliance. And this is actually something new for us. So again, just to reiterate a little bit. So we have the WAN optimization that includes application acceleration for things like CIFS, certainly ICA, XenApp XenDesktop. Video optimization through transparent forward caching. Branch services, so we have a couple models of our CloudBridge optimization appliance. It also includes a Windows server.
Okay, so this is the branch office in a box with a Bob.
We have just about, and you can. It's really flexible. You can run anything on that server that you could run on any other server. It's independent and segregated resources between optimization and the Windows services.
Okay.
And then there's this thing I mentioned just a little bit ago called visibility and insight. Getting a look at what's going on from the network layer all the way up to the higher levels of the protocol stack.
Sure.
Very, very important. And then the Enterprise Edition, which combines SD-WAN, the things that we've talked about SD-WAN, and optimization in the same appliance, getting the same visibility and manageability. So the differentiators. This is kind of my favorite slide. I could do this one in the beginning.
Yeah.
And then, but it's about use all of the bandwidth, true bandwidth aggregation. A lot of people say they do aggregation, but really it's not.
Okay.
They can't span all these flows or load balance flows across multiple circuits. Bandwidth priority and sensitivity to latency, jitter, and packet loss as an application SLA. It could be just jitter. It could be just latency, or it could be a combination of these that would degrade the quality of the application. And our logic makes the decision based on the requirements of the application.
Okay.
Measure real-time performance in each direction. I think that goes back to our packet-based solution. And then, of course, with the Enterprise Edition, accelerate ICA, the underlying protocol for XenApp XenDesktop, CIS, SMB, mapping, and there's some other ones in there. They just ran out of slide room.
Yeah.
And then do compression as well.
Okay.
Right on. And that forms the layers, if you will, for our optimal application delivery for NetScaler SD-WAN and optimization.
So this is really where you will need to be sort of setting your benchmark, isn't it? Checking out the vendor that you're evaluating before you spend your money, your hard-earned budget. These are the kind of things that are going to make a difference to the service level for your end users.
Yeah.
So these are the kind of things that you really need to quiz that vendor about and see if you can really get down into the stack. And you may need to speak to some of the technical guys because I know that we're getting down in the reeds with this. But where you're looking at networks and where you're looking at service levels, these little benefits along the way all add up to a greater benefit. It's greater than the sum of its parts, I think. So.
Yeah. Why would you implement a solution that gave you some ability to switch between circuits but didn't preserve the application operation?
So you're kind of putting the cart before the horse there, aren't you?
Exactly, right?
Yeah. Okay.
Yeah. So we have centralized so we've talked a little bit about we define the market. As an engineer, I'm a very, people have heard me say this before, pragmatic guy, where I'm very serial and I state the problem, solution.
Yeah.
But management is always a very important piece of doing this. And the CloudBridge SD-WAN solution is centralized management. Okay? So you do your configuration, you deploy your changes by default from a central location. Okay? And as part of that, we have a software package called the Virtual WAN Center that gives us visibility, collection capability for what's going on in the WAN, but also configurability for the WAN. So for your SD-WAN, so you can build the configurations offline and then export them to your SD-WAN network.
Okay.
And then apply them.
Nice.
Yeah.
Yeah, we like that.
And the reporting, because we do this on a packet by packet basis, the level of focus that we have relative to circuit operation and all of the aspect, quality of service, application flows, is really pretty impressive if you can look down, really deep into it.
Great. Lovely. Barney, I thank you for that. It's a great overview and something that we're learning more about pretty much every day. There's all kinds of things coming out and being delivered by Citrix at the moment. The questions are pretty much, I'm reading through them here, and we've pretty much covered all of them there. If anybody wants to reach out and that's a terrible term, isn't it? Reach out. If anybody wants to get in contact and ask any more of those, I'm reading through. We've spoken about XenApp. We've spoken about link load balancing. We've spoken about centralized management and these other things. So if anybody wants to get in contact with us and ask some more questions, I'm just going to click on that screen there. You can see the telephone number for the cloudDNA team in the UK, or have a look on the Twitter feed, and we've always got the new information going up on there. It is Synergy in a few days' time. Barney's going to be hot-footing his way back across the pond and going home, visiting his family and his dogs for a couple of hours, and then flying over to Las Vegas. Personally, my liver can only stand one trip to Las Vegas a year, and I did that in January, so that's enough for me for one year. But have a look at cloudDNAgroup.com and follow your nose for the SD-WAN pages. You'll find out some more information in there. But I think we've pretty much covered all those bits and pieces off. Barney, I thank you again. It's been a fantastic week. I've learned a huge amount. It's great to spend some time with somebody who's so close to the product team and the marketing bit, the conduit between the middle. So it's been a real eye-opener. And we always think we know lots of things about this, but having some quality time with you has been fantastic this week. And, of course, thank you for this session today and for coming along and helping us to explain a little bit more about how this solution perhaps fits in for some of our customers' minds. And similarly there as well, thank you to all the guys that have joined us live and for those who's watching us. And just again, if you want to get in contact, please do so. But Barney, thank you so much for your time. I really appreciate it. I know you're a busy guy.
Well, thanks for giving me the opportunity, and thanks for everybody online for sticking in there with me.
Terrific. Good stuff. And guys, enjoy the rest of your Friday. Have a fabulous weekend. My name is Al Taylor. By all means, hook me up. I'm NetScaler Taylor on Twitter. We'll keep you in the loop with all these bits and pieces. But by all means, give us a nudge if there's any questions. And failing that, have a great day, have a great weekend, and we'll see you in SD-WAN heaven in due course.
Right on.
Oh, my goodness me.